All right, folks. So for today's video, we're going to take a look at this Retevis RT95. It's a dual band radio for 2 meter and 70 centimeter. It's a relatively inexpensive radio. Comes in right now at around $105 on Amazon, and I'll have a link below that you can check out. It's a rather popular radio, and folks like it. I think it's 25 watts power output. Today, what we're going to do is a signal test. We're going to use this TinySA. Ooh, and that gets everything nice and dark, to inject a signal into the Retevis 95. And what that will do is allow us to see how sensitive this is. You can take a look at the back of the radio, and I've got some coaxial cable coming out, and it is going into a 40 dB attenuator that's rated for 10 watts. Now, this radio can do more than 10 watts, but we're injecting into the antenna port, not out, so we're safe there. And then this cable comes all the way around, and it goes into the TinySA. Now, we're going to configure the TinySA to act as a signal generator to do this test. So let's go ahead and get started. Okay, so the first thing I want to do here is I want to take a look at how the radio is configured. So if I hit this button, I can go to volume, and we're set at volume of 5. That's just what we're picking, and that's what we're going to go with. Now, if I hit this function button again, I get an option for band, and I can push that. And right now we're set to narrow. We're going to go ahead and we're going to set that to wide. And the last thing is that we got to set our squelch. And I do that right here, and our squelch is now turned off. And that works best for this test. Okay, so let me just show you something real quick. And it's a chart that I put together that talks a little bit about signal strength and how it's rated. So you can see here on the right-hand column for UHF and VHF, an S9 signal is negative 93 dB. And that goes all the way down to S1, which is negative 141. Now, what we've seen in similar tests like this is most radios stop at somewhere around 938 to 940, somewhere right around in that range, which I would consider acceptable performance. So what we're going to do is we're going to test this. We're going to test this Retevis starting at negative 93 dB. Now, remember, we're using the 40 dB attenuator. So we're going to set the TinySA at negative 53, and then we're going to increment down until the TinySA signal is no longer heard by the Retevis, and that will let us know about what our sensitivity is on the radio. We're going to do this for both 2 meters and 440, so let's get started. So as you can see here in the test lab, we have a very sophisticated setup. Let's go ahead and get this all configured. So what we want to do is I hit this drop down, and you can't see the menu. I'm going to hit mode, and then I'm going to go to spectrum signal. I'm going to go to signal generator. And the first thing I'm going to do is when we get here is I need to set our frequency. So I go to set, and I go 146.52 megahertz. So my signal's correct. Now I need to adjust my level, and then I'm going to hit set to do that, and we're going to go negative 53 times 1. That gives us our negative 53 dBm plus 40 for our attenuator, gives us our 93. Make sure you put the negative sign in this if you're playing along at home. And for this says mod for modulation, and we're going to go with FM, and we're going to stick with this FM deviation of 3 kilohertz. We're going to go back. And what I'm going to do now is I'm going to turn it on. And what I did down here, because the static sound was driving me nuts, is I turned this down to 1. So now we're back at 5. And you can hear a nice clean tone at an S9 level. You can see our meters pegged out. So what we want to do now is we want to go down 10 dB. You can still hear it. You can still hear it. Starting to lose it a little bit at negative 83 plus 40 would be negative 123. All right, there we've lost it. That would be 133, which is a little bit lower than what we've seen in some other tests. Let's go back up, and let's see exactly where we lose it. I could still faintly hear it there. I don't know. Very, very faint, but I think we're going to say that that's about it. So that would be negative 133, and we're going to call it quits. Let's go ahead and check 440. All right, folks, so now we're set up to do the test on 440. We have our frequency set for 440. It really doesn't matter. We're not broadcasting anything. Or transmitting anything, I should say. I wouldn't want to use the wrong terminology. And anyhow, we have our frequency set on our TinySA, and we've set the level to negative 53 to give us an S9 signal. let me go ahead and turn this on. You can see it here. Let me go ahead and adjust the volume. And you can hear a nice clean signal. Let's continue to increment down 10 dB at a time. So now we're starting to lose our signal a little bit, and you can hear some static. Let's go down to 93. And I don't hear it. So this is similar to last time. So we're starting to lose our signal at around a negative 133, negative 134. Let me go ahead and turn this off. So one of the things I wanted to show is this chart. So we're getting down to around an S2 signal, which is getting down pretty low. What I would say about the performance of this radio is that I think for $105, you get a lot of capability for this radio, and this is just fine. With that, we're going to wrap up the video, and I'd like to say thanks for watching, everybody. If you have any questions, comments, suggestions, or recommendations, go ahead and post them below, and I'll do my best to respond. Thank you very much.